So this lesson is going to be split into two parts. The first part today is just the taking some notes, and then there's the last four problems on this presentation you're going to submit to Schoology as an assignment. So we have two objectives today. We're going to apply something called the SSS postulate and the SAS postulate to construct triangles and to solve problems. And then we're going to prove triangle congruence using those two postulates, SSS for side, 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 and SAS for side, angle, side. And we'll learn what they are in just a second. Ugh. Stupid thing. So two new vocabulary terms we're going to use in stupid thing. So two new vocabulary terms we're going to use in a minute are triangle rigidity and included angle. We have two new vocabulary terms. One is the idea of triangle rigidity. Now something's rigid, it's not flexible. It's solid and it doesn't bend very well. And so think about that when you're making a triangle. The sides are straight and they don't bend. So they're rigid. And the idea of an included angle, and we'll describe that in just a minute. When we proved triangles were congruent using the definition, we had to do 6 different things. We had to show all 3 sides in the first triangle were congruent to all 3 sides in the second triangle, and that the corresponding angles in the first triangle were congruent to the corresponding angles in the second triangle. Well, this idea of the rigidity of triangles, the sides of a triangle, gives us a little bit of a shortcut. And so this triangle rigidity, the idea is that once you have the side lengths fixed, there's only one possible triangle that you can make out of those 3 sides. And no matter how you put them together, you're going to get that same triangle. It might be turned in the, look slightly different because of its orientation, but it's going to be the same triangle, the exact same shape. So the first postulate is the side-side-side congruence postulate for triangles. And it just says that if 3 sides of one triangle are the same as 3 sides in another triangle, then those triangles are congruent. And you can see here that they color-coded the picture. So we have the red side is 4 centimeters here. The red side is 4 centimeters. 6 centimeters is blue, 6 centimeters. 7 centimeters is green, 7 centimeters. And clearly those triangles are not oriented the same way, but their side lengths are the same way. And I could rearrange it in space so that they would be right on top of each other and they would be exactly a perfect fit. They would be the exact same size. The other thing to notice is when you name them, you have to be very careful about order. So we've talked about that before, but here, if I'm talking about A, B, C, I went red, blue, and then I'm going to be green back to A. So if I'm ABC for the first one, the next one I have to go the same order. I have to do red, blue, and then it would go back to green. So it's going to be F, D, E. ABC, F, D, E. Be very careful about how you name them. That I had here. So one important idea is that many times when you're solving these problems, you have a triangle and there's a line that splits it, a line segment that splits it into 2 smaller triangles. Well, keep in mind that those 2 smaller triangles now share a side that is the same length as itself, of course, because if this is side AB, well, that's AB is in both triangles. So this side AB is going to be congruent to itself. And that's called the reflexive property of congruence. So you always know when you have a side that it's in both triangles that you can use it as 2 separate sides in your explanation. Continue to go in the order. Okay, so the very first example is we're going to use the side postulate to prove that these two triangles are congruent. And so it might help. I like to do this. You don't have to, but it's a suggestion. I'm going to mark the sides that are marked as congruent with the same color. So I marked AB and BD with the green because they are both have one tick mark. And then AC with two tick marks is going to be the same length as DC. And then the third side is the BC, and that's in both triangles. And so that's that idea where it's going to be the same length as itself, which is kind of a somewhat strange idea, but yet um, seems to be true, right? And so let's start with the same order that the triangles are named. So it says AB, so I'm going from the A to the B, and so from red to the blue on the green side. So I'm going to go from red to blue on the second triangle. So AB and DB are congruent. So I say AB is congruent to DB. And then the next side that we have is we do AB, then it's going to be BC. So here's BC. Notice BC is in both of them. And so BC is going to be congruent to itself. So we're going to say BC is congruent to BC. That's the reflexive. Sounds a little bit like a reflection when you look in a mirror, but reflexive property of congruence. And then the last one, we're going to go in continue in the same order. So it's going to be CA and then CD. So remember, order is important. So we get AB, BC, and then it's CA. DB, BC, and then CD. So the last one is in red. So I'm going to say CA is congruent to CD. And there we've shown all three sides are congruent. So by side, triangle ABC is congruent to triangle DBC. Okay, so now we're going to talk about the idea of an included angle. An included angle is the angle to CD. And there we've shown all three sides are congruent. So by side, triangle ABC is congruent to triangle DBC. Okay, so now we're going to talk about the idea of an included angle. An included angle is the angle formed by two adjacent sides in a polygon. So we're talking about triangles. So the included angle is the angle that's between the two sides you're talking about. So if I'm talking about angle B is the included angle for these two sides, side AB and side BC. So the included angle is the angle between them. And that will be important because the next theorem we're going to, postulate rather, we're going to talk about is called the side angle side theorem. So side angle side is between you use two sides, one angle. But that angle can't be any angle. It's got to be the angle that's between. Notice that when we write side angle side, that A comes between the two S's. And so it's really important that when you're using side angle side, that you have a side, the angle that's the included angle between that side and the adjacent side. So order is really important when you're using that. So the idea of an included angle. So it turns out that it's sufficient information to know that two sides of one triangle are congruent to two sides of another triangle if you can show that the angle that's in between those two sides, the included angle, is also congruent. And so this is the side angle side congruence postulate. And you can see on our picture here that we have two sides. We have the side AC, and it's congruent to side ED, and they are in green, and then side AB, which is congruent to side EF, and that's in blue, and then this angle is the included angle. So angle E and angle A are also congruent to each other. And if that's true, if you can have the side, the angle in between, and then the adjacent side congruent to the side, the angle in between, and the adjacent side of another triangle, then you know the two triangles are congruent. So again, to emphasize, the order is really important. That angle has to be between the two sides. It has to be the included angle. Otherwise, it's not true. So that angle is the included angle between those two sides. So here we have two triangles, and we're going to, in the directions say, use the side angle side to explain why they are congruent. And so I'm going to mark the sides that are congruent with some colors. So here I have YZ, and it's got two tick marks just like WZ. So I'll mark those in green. And then XZ has one tick mark. So VZ is going to be also the same length. And you can see that we have no information about these other sides on the ends, the WV and the YX. So we don't know anything about those two sides. But we do know something about the angle. And if we look at this angle that's in the center here, and the other angle that they meet at Z, those two angles are vertical angles. And so we do know that vertical angles are always congruent. So you can see that this setup is just perfect for having a side, the included angle, and the other side, the adjacent side, being the same, congruent to the side, the included angle, and the adjacent side. So that's how we're going to explain this. So this particular triangle pair is congruent because of side angle side. So let's start with the first side, and it doesn't matter which one we pick, but we can maybe follow the congruent statement. So it starts with XY here and VW. So here's XY and VW. We don't know anything about those sides, so I can't use that. But I can use YZ. That's what comes next. And so here YZ is green, and YZ is going to match WZ. So YZ, WZ. So I'm going to start with that. We'll use the green pen, and we'll say YZ is congruent to WZ. And it really wouldn't matter which side we start with, but just make sure that you're going in the correct direction. So here we have, when I finish with YZ, now I'm at the angle. So let's talk about the angle. So this angle is going to be YZX. So I'm going to, maybe I'll use yellow for the angle. So angle YZX is going to be congruent. So when I did YZX, I went green, angle, blue. So I'm going to go green, angle, blue for the other angle. So it's going to be WZV. So angle WZV. And then the last bit is the third side, which is in blue. So we can see that side, angle, and so I'm going to have ZX and ZV. So we're going to say ZX is congruent to ZV. And therefore, we've shown that the side, the angle, and the side are congruent. So therefore, we know the triangle XYZ is congruent to triangle VWZ. So the idea with the side angle side theorem is this: that if I had two lengths, two segments like this blue segment and this red segment, and I put them together to make a triangle angle, okay, there's of course one side of the triangle that's not drawn. It's clear that if I adjust this this angle, I'm going to be changing the length of that other side. But once I fix that angle to a specific length, let's say I said this angle is going to be at 30 degrees, then this length is predetermined. It's not going to change. And so the idea that if I know the lengths of two sides of a triangle and the included side, there's exactly one and only one triangle that you can make with those specifications. So here I have two triangles, and one triangle has measured numerical lengths. The other one, it has algebraic expressions. But they tell me that the two triangles are congruent, and they tell me that x equals 5. And they want me to show that these are going to be congruent. And the idea, when I put in that 5, it's going to give me the other side length. So I'm going to be using the idea of side, side, side to show these are congruent triangles. So all we need to do is put in the numbers. So I hear 5 is my input, and I'm adding 2. So this side is going to be 7. Here, this is x is 5, and this one's going to be 3 times 5, subtract 9. So 15 minus 9, which would be 6. And so we can clearly see that my sides, I have a side that's 7, a side that's 7, a side that's 5, a side that's 5, and a side that is 6, and a side that is 6. So by side, 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 I know that these two triangles are in fact congruent. So this example is very similar to the last one, except for you can see in this case that we have, instead of 3 sides, we have a side, and the included angle. And so when we examine this one and demonstrate, we're going to be showing that it meets the side, angle, side criteria for being congruent triangles. So my input is 4, so let's see what we get. We have 4 plus 3, so this side is going to be 7. And then 20 times 4 plus 12 for the angle, so that's 80 plus 12, so that's going to be 92. And then we have 2 times 4 plus 3, which would be 8, 9, 10, 11 for this other side. So let's see if we can match them up. So we have a side that is 7, a side that is 7, a side that is 11, and a side that is 11. And then the included angle between those sides is 92. And so we've shown side, angle, side. Therefore, these triangles are congruent. All right, so in this problem, they want us to prove that these two triangles are congruent. And so the very first thing I would say is, let's look at what they tell us. And they're telling us in two ways, the information. They're giving us a written notation, and then they're also showing us some things on the picture. So here it says BC is parallel to AD. Actually, this should have the little lines over the top. And that is shown in the picture by the little arrows on those two line segments. And they also say that BC is congruent to AD, and that is shown on the picture by the single tick mark on both of those. So the first thing I want to think about is, I'm going to have to choose between side, 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 and side, angle, side. Do I have enough information to show that this is congruent by side, side, side? Well, this side clearly is congruent to that side. So that's two sides, one pair of sides rather. And then I know that this middle side is in both triangles, so I could use that as one side. So what I have is I have two pairs of sides that are congruent to each other, the blue and then the red, which is in both triangles, so it's congruent to itself. I do not have any information though about AB and CD, so I am not going to be able to use the side, side, side theorem, so that's not an option. So I'm going to have to do this using side, angle, side. So how do I know anything about this included angle? So where is the included angle first? So the included angle would be between where the red and the blue meet. So here is the angle, and here is the angle. Can I show that those are in fact congruent? And I can, yes, because they tell us that these two lines BC, these line segments BC and AD are parallel. And if that's true, then this angle pair right here is a pair of alternate interior angles. And we know if the lines are parallel, then alternate interior angles are congruent. So that's enough information for me to be able to use side angle side. So let's go through and write those things down. So I'm going to use the blue pen and we'll talk about the first bit of information. So first bit says BC, side BC is congruent to side AD. How do I know that? It's given. So that's the first side. Then let's talk about the angle that's the included angle. So I wrote that in yellow, so I'm going to use yellow. I think you'll be able to see it. And so this angle is congruent because of the fact that our lines are parallel. So we're going to write BC, line segment BC is parallel to line segment AD. And we know that because it was given to us. Okay? But that implies something. So that means that the angle CBD, so I went careful, blue, angle red, right? Angle CBD, I'm going to have to go blue, angle red, is congruent to ADB. So it's congruent to angle ADB. And what was our reasoning for that? It's because alternate interior angles are congruent if the lines are parallel, which we know they are parallel. So far we have the blue side, the included angle, and now we have to talk about the red side. So we have to be careful about the order here. So we did C, B, D. So if I'm going on this angle, I'm saying B to D. If I'm going the other way, I went A, D, B. So what I'm going to say is BD is congruent to DB. I'm going to go backwards for the second one. And so we'll write this in red. So BD is congruent to DB. And how do we know that? What's our reasoning? That's called the reflexive property of not equality, of congruence. So the reflexive property of congruence. And so those are the three things I needed to show for side angle side. So I can say, therefore, triangle ABD is congruent to triangle CDB by side angle side. Okay, at this point I would pause the video and take a little break because now you've been taking a lot of notes. And when you come back, what I want you to do is there's going to be 4 problems, 4 check it out problems. Each problem is going to be followed by my solution. So what I would do is I would copy the problem, solve it, check your answer against mine, and then move on to the next problem. When these 4 problems are done, you can submit them to Schoology and you're done with the assignment. So this asks us to use side, side, side to explain, and you can see that I have 2 tick marks on these sides. They correspond. 2 tick marks on, or 1 tick mark on AB and DC. They correspond. And then that third side is one of those sides that's shared in both triangles. So of course it's congruent to itself by that reflexive congruence property. So to do this, I'm going to be looking carefully at the congruence statement to match things up. So the first 2 letters are AB. So AB is in blue. I'm going to use my blue pencil. So I'm going to say AB, side AB, is going to be congruent to side CD. And I'm just going in the order here. Remember, orders, we got to be very careful when we're talking about congruence. So now the next 2 letters are BC. And if I look at my picture, I use the color red for that. So I'm going to say BC, side BC, is going to be congruent to side DA. And then, so far I've done AB, BC, now I'm at CA. So for green, I'm going to say CA, and that's going to be congruent. And so here I did AB, So I did blue, I did red, then green. So I did blue, I did red, and I'm going to do the green here. So I'm going to say AC for this one, because if I continue in that same order, I'm going to call it CA. So it's congruent to itself because it's the same line segment. And so so by side, 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 these are congruent triangles. Triangle ABC is congruent to triangle CDA. So pause the slide here, solve the problem, and then continue to see the answer. So how do we show that these are these triangles are congruent when t equals 4? Well, we're going to put in our values and see what we have. So as I look here, we can see that this side is in both triangles, both in triangle ADB and CDB. Also, I can see that by the naming, AD and CD go together. So I'm going to be expecting that that this side AD and CD are going to be the same. So I've got everything matched up, and so let's go ahead and check it out. So I'm going to put T as 4. So 3 times 4 plus 1 is going to be 13. And so I should also get 13 when I do 4 times 4, which is 16 minus 3, and I do. So those are congruent. And then I just have to check and see that when I put 4 in, if I square 4 and then double it, that I get 32. So 2 times 4 squared, which is 16, that is 32. And so this matches as well. And that's the angle. And why don't I have to verify that DB is the same as DB? Because it's itself. And so I don't have to check that out because it's the same line. And so therefore, I've shown by side angle side that that these triangles are congruent. So we can say this is true by side angle side. Okay, so pause this slide and then check out the answer on the next slide. Okay, so pause the video, and when you start it again, it'll show you the answer. All right, so here we have some information that QP bisects angle RQS. Remember, bisects means it cuts it into two congruent parts. So what that's telling me is that this angle RQS has been split into two congruent parts. So we have this angle RQP is going to be congruent to angle SQP. All right, so we have that. And then we can see that if I look where the tick marks are, that RQ is going to be congruent to SQ because they both have one tick mark. And then, of course, in the middle, we have this shared side QP. And so those are the 3 parts we need. And you can see we're doing side angle side here because it's got 2 sides and the included angle. So we want to use side angle side. So let's just go through and make our statements. We say QR is going to be congruent to QS, and that was given. And then what else do we have? Well, we have the angle in between we can say that QP, ray QP bisects angle RQS. So what does that mean? That was given, okay? So then that tells us what? That tells us that angle RQP is congruent to angle SQP. And why is that true? Because it's the definition of bisecting an angle. So definition of bisect. So now we have, so far we have the one side, we have the included angle. The last bit we have to say is that this side QP in both triangles is congruent to itself. So QP is congruent to QP. And why is that? It's because it's the reflexive property of congruence. So those are our three things. So our final conclusion is going to be therefore triangle RQP is congruent to triangle SQP by the side angle side postulate.